Good afternoon.
Good afternoon.
Wow, that was a good start. How are you enjoying NAV TechDays? Hopefully really good. Cool. So welcome to our session, one of the most unclear titles, I guess, that you could think of. I'm Wouters from Belgium. This is Vjekoslav Babic, and actually we are not that. We are Aldo and Vjeko. So what we will be doing...
Sorry, excuse me. Waldo and Vjeko, but it says Vjeko and Waldo.
Yeah.
Why do you have to be first? Like, it doesn't make any sense that you are first. So, yeah, let me introduce this session because my name is first on the slide. So, welcome to this session called Evolution of a Titan, a look at the development of NAV from an MVP angle. So, what we are going to talk about today has...
So Vjeko.
Yep.
What's this here?
I don't have a clue. What's that, a piano?
Yeah.
Yeah, looks like a piano to me.
Can you play that?
I can press keys, come on.
Can you press keys?
Yeah, look. It works.
Cool.
Yep.
Let me try.
Come on, can you do something? Really?
Watch this.
Yeah, that's what I thought.
Better?
Much better, but watch this. Cool. Well, obviously we can still do a little bit of that. So, as you might have guessed, well, I need that thing over there, not piano, that thing. Yeah. So, we are two old and grumpy guys that will just take a funny look from the balcony at what has happened over the past 15 years and where it has led us to, and then where we will go. So, you might know these two guys. They are Waldorf and Statler from Muppet Show, and that's what we're...
It should at least be Waldo and Statler.
Well, fine with me then.
So
yes.
let me fix that for you.
Okay, fix it. No. That guy is Statler. That's Statler.
But
that's not Waldorf.
just continue. No one cares.
Okay. Well, good. Let's get the crap. So, let me start with this. If you don't have a problem, you don't need a solution. So all of the development of NAV or Business Central, if you want, that has happened in the past has been a reaction to some kind of a problem. So when it all started 25 years ago, is it 25? 35 years, wow, 35 years ago. This is what it looked like, and the problem that this thing tried to solve is let me handle my business processes as a single person. And then as soon as that problem was solved, another problem came along. So how to get more people in the system. And then in 1987, Navigator came along. And then as that system came along, there were more problems. How to get even more people to the system. How to integrate with other systems. How to provide better performance. How to allow web services. There was a number of problems. And as we went along, more problems came along. And we had to solve more problems. So out of all the things that happened in past 35 years, and especially in the past 15 years where things really kicked off after Microsoft took over, I would like to bring these kind of holy grails to our attention. There were things like, for example, how to provide world-class scalability. That was something that was a barrier hardly to be broken for years. Microsoft was trying to kind of get more people to the system. Remember all those days when, pushing more than 50 people really hurt. Anybody who had 100 people, it was like, wow, a crazy implementation. there were stories told about implementations with 250 people and stuff like that. Today, nobody asks that question anymore. You don't think, can I put like this number of people on the system or not? Architecture just scales. When you think of cloud, you don't ask like, what kind of cloud architecture do I have to have, in fact. So if we take a look at architecturally what happened over all this time, we started with a single tier, then we went to 2-tier, where we had the client and the database. From that, we went to a 3-tier architecture. But today, barely anyone is talking about architectures, because what we have on one end is clients, and then on another end, we have this big cloud of things that is just connecting all of that together. And this is our architecture. So it's not a real architecture, it's really clients connecting to a cloud of different kinds of services.
Exactly, and a cloud of things is a nice way to put it. I call it technologies, and we've got a lot of technologies actually that we can think of that actually connects with our environment, our life as a developer. So we are not going to bore you. These 90 minutes we're talking about all of them. So we picked what we think influences our life as a developer in this time, in the near future, let's say. So, going forward, it's a good way to look into the roadmap, let's say. So if we look in the roadmap and we look in the future, I think I just want to focus on one thing for now. That's this thing, modern clients. What does that mean? I mean, we have clients, they are quite modern, even new clients. So modern clients in 2020, what does that mean? Well, actually, from all the collection of quite nice looking, cool clients that we have been using in the past, only the modern clients will survive. The modern phone client, the modern tablet client, the modern...
Sorry, but if I just may interrupt again. Modern. What does it even mean, modern? If you think of any of those clients that we have seen, all of them have been considered modern. Nobody was releasing a new release of an old-fashioned client. It was just, you know, here's a new modern client. So, modern. Let me show you what modern is. So, I just want to show you what I think is a modern client. So, I'm going to connect to my local instance to a modern client, and
now you make me curious, Vjeko.
Yep. Okay, so
well.
This is pretty modern as far as I. So, let me try to see like what my customer list. Oh no, sorry. What I did like I clicked on orders. Let me try to. What was that? Yeah, I want to go to sales orders and then maybe click on this one and try to post that one, or yeah. Let me see. So you know, if you ask me why doesn't it work, I need to post. Yeah. So I would like to ship an invoice.
Yeah, nice
so that's modern client if you ask me. So
very nice. Very nice, but I have no clue how you did that.
Well, how I did that, it's JavaScript, obviously.
But still, this is cool to show.
Yep.
But on the other hand, is this functional? I don't think so. Do you have anything functional that you can do with it?
What do you mean functional?
Yeah, something really useful. Like when you think of modern clients, and we are all afraid of going to modern clients for one simple thing, I think, it being shortcuts. We are not able to use shortcuts anymore.
Come on. So shortcuts. Shortcuts like, for example?
Post.
But what is that shortcut?
F9, I
F9.
guess.
So sales orders. This is obviously the real modern client. So I'm opening a sales order here. And what is this posting, right? I need to, this is what I need. Yeah, okay, let me move.
Yeah.
So I'm going to press F9 on my keyboard. And is that what you're looking for?
That's what I'm looking for.
Good, pretty good.
That's nice.
So
let me just
cancel that, and then let me try to see what F8 does. Nothing. Let's make F8 do something, shall we? Cool, good.
Please.
So here I have a little solution where I have shortcut listener, and then in this page I will subscribe F8 to an event, and then let my JavaScript take care of the rest. So I'm publishing this, and is this published? No? Oh, it is. I'm closing the browser I want to do. I can do it from the browser too, but I want to show that it works in the client. So I'm going to sales orders, and I'm going to a sales
This is
order.
the universal client you're showing now?
And sorry?
This is the universal client
That's the
you're showing?
universal client, yeah. So what I bound my action to is this shipments in here. And then I'm going to press F8 to run that shipments page. So, is that useful?
Is that useful?
Would
I think so.
Okay, good. So, yeah, okay, before you get too excited about this, you will get the source code of that. I did a little cheating, not much, just a little bit. And Microsoft will hate me for what I'm about to say, but I wouldn't have to do any cheating at all in this demo if the architecture of the AL code was correct. So, unfortunately, all of that code that runs when you press F9 or F8 or click those actions is on action triggers in pages, where Microsoft is saying do not put your code in pages, and yet they put their code in pages. When that code is off pages, then we will be able to just do no tricks here. Until then, this works with just, little bit of tricks. So let's talk a little bit about JavaScript. Obviously, my suggestion would be that if you want to invest in one single piece of technology or one language, new language that can really boost your development, then you should go with JavaScript. Yeah, and I hope I survive.
Go there.
Yeah, I will. I'll try to stay here. So JavaScript is a powerful language. It really allows us a lot of things. You have seen that using JavaScript, I have been able to hijack the entire client. I have full control of the user interface. I can really do anything that I imagine. When we think of controlladins, which is where JavaScript lives, then we typically think of things like this. So for example, I will go to, yeah, even escape doesn't work there. I'll fix that. Remind me to fix escape. Yeah.
Okay, I will take a note.
Yeah. So I will go to customers, and here I have my customer list, and I want to rate my customers with stars. So this customer is obviously a great customer, but it's lousy at payments, and then this, yeah, what is happening? This is happening. Yeah. So let me rate this customer like that, and then let me prove that it really, yeah, it does remember. So this is an example of a controlladin that people have in mind when talking controlladins in JavaScript. But obviously, it doesn't have to be that. It can be a lot more. However, JavaScript is not a language that we are all used to. It's vastly different from most languages that we have seen. So let me just quickly prove that. I have my Node.js environment here, and let me just do some simple test. Like for example, any language would pass that test, right? 1 = 1, that's obviously true, right? But in JavaScript, for some reason, this is also true. Well, makes sense, obviously. Yeah, 1, those quotation marks, whatever. But what if I try that? Yeah, that's true for most C-based languages, that will be true. But what if I do this? Will that be true? Well, that's true as well. So that means that I should be able to do this as well. Well, that's obviously false, because it makes sense, right? So sometimes, not all things in life make sense. That's not all. Let me show a little bit more about JavaScript. So obviously, we know that now, we know that this is true. So it means that if I do, that this is false. If I do true, then I print true. Obviously, if I put false in there, then this will not print. But if I print, if I print that true, which we know is not equal to true, that will still be true. So let's take a look at a little more. So I absolutely love this one. So Waldo, I put you in an array. Is it fine with you?
Yeah, fine.
Good. This is true. But if I put Waldo in 2 arrays, this is obviously false, right? it just makes sense, right? Well, in JavaScript, we have this concept of truthy and falsy, and you just have to live with that. This is just one of the quirks of the language. Eventually, you get used to that. But even though it's a very crazy language, it's also a very powerful language. So let's just take a look at what else can we do with that language. So I'm going back to my real modern client, unfortunately, this one. And I've always, but always wondered why in the web client we have this user icon in the upper right corner if we cannot change that. So I just decided to make it possible to click that icon, and then on click of this icon, it starts a webcam and then takes a picture of me. So for example, I will now take a picture. It didn't succeed. So because you pushed me, so let me now
take a picture.
Yeah, so I will take a picture of me, and
so now you have a dick pic.
Yeah. Good. So that's just an example of how I would like this to work. So yeah, I will cancel that now. I have my picture already, and to prove that there are no smoke and mirrors, I will just restart the session, and it shows picture out there. So these are things that JavaScript as a language can really do for you. So I would dare saying that after AL, JavaScript or addition of JavaScript to NAV technology stack is the #1 thing that has happened to us. Because if anything can open up horizons, it's JavaScript. And if this worked, I would be even happier. I also have some, dreams, like what I would love to see in the future. Unfortunately, currently, when we are working with the universal client on Windows, we are using Internet Explorer down there. So Microsoft has given up on Internet Explorer, how many, 6 years ago? Something like that. And yet we are confined to that thing. I know why is that like that, but I hope that eventually we get rid of that so we can get access to, for example, ECMAScript 6. Also, what I would like to have is I would like to have callbacks that when JavaScript completes the work that AL gets a callback that JavaScript is done, that will allow us a lot of different things. And one thing that I would definitely love to have is a permanent JavaScript layer. So a piece of JavaScript layer that we can always call from AL rather than having to put our crazy control engines in there to be able to communicate. Why do I think it's good? Because if you think of crazy people like, for example, me, I do these crazy things like color the client in pink colors and put the icons of Muppet Show. Because if customer asks for that, and if that's possible, we will make it possible. We will make it work. We will break all the barriers. We will break the rules just to achieve that thing. And wouldn't it be better that if we have a nice piece of architecture behind that allows us to do that without having to pull any tricks? This is what I'm calling for and what I'm hoping for.
So you did now quite some rambling on your baby. I got a baby as well.
You get baby.
Yeah, a few of them, by the way. But PowerShell.
PowerShell, come on. PowerShell. PowerShell, what has PowerShell ever done for us developers?
Oh, come on, you cannot mean that.
Of course I mean that.
It did some simplifications on installation.
Installation, okay. Installation, fine.
And for merge and comparison, like object merge and upgrade.
Good. Yeah, okay, but I don't care as a developer. Like
administration part.
Okay, administration, I give you that, but
absolutely.
That's what PowerShell is for, administration. That's my point.
Okay, but for deployment, like deploying your objects, your deltas and stuff like that.
Well, good deployment, fine.
Security.
Okay, but apart from installation, comparison, and merge, administration, deployment, and security, what has PowerShell ever done for us? Really?
PowerShell does a lot for us. Except from these and backups and upgrades, it does a crap load for us. A lot more as the boxes that you see here. Sorry.
No, I did nothing.
Well, I must admit some of them are fake. But a lot of them are not fake. And PowerShell does a lot for us in terms of NAV development. So if we go back for a minute in time to NAV 2013. NAV 2013 gave us quite some possibilities with PowerShell. This was actually our first baby steps into PowerShell and the connection with NAV. We had some administration parts where we could update settings from the server and stuff like that. We could even publish web service. We can still do that, by the way. We could do stuff with companies. The worrying about, but now users that are not users from NAV will be able to, yeah, that's all possible. In NAV 2013, Microsoft put time in the merge tools. We were able to automate upgrades with PowerShell. And I hope a lot of you are using that possibility because it immensely, it is an immense help in the upgrade process. And obviously also language management. It was thanks to PowerShell that I came to the conclusion that I need to translate about 12,000 captions in my solution. So I had a problem, thanks to PowerShell. I hate PowerShell since then. But anyway, on top of that, what do we do currently? I think a lot more still. Now we have Docker, we have, obviously the entire upgrade process. And we have, hey, look at that, source code analysis. Interesting. How can we do source code analysis with PowerShell? Well, I would like to go a little bit deeper in that, to be honest. So, I don't know if you know it, but there is a DLL somewhere in the client folder. It's called Microsoft.dynamics.nav.model.tools.dll, actually.
That's not on the slide.
Sorry, I'm lying again then. It's a fake extension. So, what does this do? Well, actually, this is what Microsoft created. It builds actually an object model from the text files that you're exporting from CAL to be able to merge. So, this is actually the merge tool, the binaries, let's say, of the merge tool that we are using in PowerShell. Yeah. So, I got this clever developer in my company, and he said, we can do maybe a little bit more. So, what he did is he applied some magic. He did actually wrap around this DLL, because what Microsoft already does, we don't have to do anymore. If we can build already an object model from the text file, maybe we can build our own object model from whatever text is in the text file, being the code, right? Because that's what Microsoft doesn't do. Microsoft does not build an object model from the code itself. So he did that, and basically now we are able to make that available in PowerShell, to make actually code analysis available in PowerShell, which is useful in build scripts. Just imagine that you upload your code in source control. You could check the code. So let me try to, I even have a small Kermit showing that I will going to show something. And that's my PC, right? Okay.
It is.
So, let me show you a few bits and pieces. That is PowerShell IZ. I personally do not use PowerShell IZ anymore. You can see that.
Yeah, I can see that.
The reason why I still use it is I wanted to show you this progress bar. This is something that VS Code doesn't show. What I'm doing now, I'm actually using the DLL that we created, which is that wrapper around this model.tools. This is the DLL that is just using this import of the text file, building that object model. That's actually the first two bars, and the second and third bar is actually the where used. That's something that we built on top of that object model. We're actually going to use and map the references. And in the background, we are filling this variable. It's quite a variable. Let me show you memory. At this moment, PowerShell is using 2 gigabytes of a 130 megabyte file. So it is quite a model in the background, I must say, in memory. But the thing is, all references are there. So from code, the variable in code, the variable I'm using in code refers to some kind of type, refers to let's say the customer table, which is used in code anywhere else. So all these references and the entire path can be tracked in thanks to this model. Let's see if we can have some examples. I have a few, you see. Did not prepare anything. So this model variable here, the nice thing is now that is something you can really understand. So you see here, for instance, there are nav objects apparently in text file. Cool. And in these text files, I can count the amount of variables. Objects. 5,807. Is the screen big enough? Yeah, apparently it is. Let me zoom in maybe a little bit. So 5,800 objects in this text file. What the tool also does is going to make this an understandable object model so that you can actually read it and refer to it by keys. So this full name is actually a key to a specific symbol within the text file. And you see we have quite some symbols. Let's just take code unit 80 here. I simply going to filter on object type, object ID. And in that case, my variable cu80 should be only one code unit. I can check that, and yes, code unit sales post. So this is kind of a key I can refer to, I can work with to refer to whatever else. I can count the number of procedures, about 300 functions in code unit 80, and I'm already doing some kind of analysis. Weird analysis, counting procedures, but still, a code unit with 300 procedures, something you should have questions with, in my opinion. The variables, there are 144 variables. No, there are 144 global variables. Again, a question you should ask yourself. The code that I'm checking in here, do I want this, right? This is why I want this in PowerShell. Check the code and check it if I want this in my product. So I'm going to skip a few because Vjeko is really
I'm fine.
anxious.
I'm
No, okay.
learning.
Good, I'm not skipping any. So you see here from the 20th procedure, I can go into the local variables, and this is cyclomatic complexity. So during this code analysis, obviously a nice thing to see is how complex is my code. Now, a way to measure that is the quantities of ifs and repeats and cases you are building. So number of ifs, if you have 5 ifs, embedded ifs, yeah, that's quite complex. So the complexity is added by 1, and basically you just count the number of ifs, cases, repeats, with these kind of statements, right? And that's also what we did. So by this DLL, I know that there are 294. That's not really interesting, but an average of a complexity of 2.7, and you can measure that. Now you can measure the complexity of your code and have a threshold, and if a certain procedure or a certain code unit is too complex, you can refuse that. Yeah. This code analysis is done by code model. So this is the part that is new, and that is actually done quite simply by not simple. I shouldn't say that because I didn't do that. It was that magic developer that did that. But it's going to take every word out of that and map it. And if it is not able to map it, well, then there's a problem. So we kept on building on top of that so that we could map every single word in a code line. And a mapping can be a statement. A mapping can be a variable or any kind of something that it already knows. So if you see here, for instance, and I need to zoom out now because it's at the end of the table, here you see that we have spaces, new lines and stuff. All characters and words are being mapped, including the ifs and repeats. So if you're going to measure that, you see that there are 2 ifs or repeats in this piece of code of the third procedure. And that's how we basically building the complexity where we can add on top of that. So if the base model is there, you see here that we do other stuff, by the way, like publishers and missing elements. So if the base stuff is there, we can create scripts in PowerShell, obviously, to build yet another information kind of thing that shows us, let me quickly run this, shows us an analysis of code complexity, in this case of the first 1,000 objects. So you see here right away my most complex functions. Not my most complex functions, these are Microsoft's most complex functions in the first 1,000 objects, right? And you can see here from 1,000 objects an average of 1, which is quite fine, so the average is really good, and so on. Commits. Another thing that you might want to analyze.
I want to have commits.
Yeah, because you like to cut fingers off your hands.
I remember that.
Yeah, of course. So this is a kind of analysis I tend to like, and let me zoom in that for a bit. So just to go over that, there are more than 1,000 commits in Microsoft's code. spread over more than almost 900 functions. 14 of them are in comment, and 22 have a comment. So they explain 22 commits. They don't explain all the 1,060 others. Then per type, just spread over type. So we have 174 commits on pages. Okay, you might wonder, why do we have this? We are talking about evolution, we are talking about going forward, the future, and you're talking about CAL. Okay, point taken. My point to myself. This is an example where we use the model to go forward, to try to build tables that are in AL but don't have any code. Makes a lot of sense, believe you me. This is a good opportunity, this AL conversion, to not convert, but to refactor. And a good way to refactor is to rewrite your code. Thing is, rewriting code shouldn't be rewriting your tables, right? So in a way, it should be nice that you could export your tables without code and then convert them to AL. So what we did is do it the other way around. We analyzed our code. We built some kind of function print nav table, which is going to produce AL files. This is the function that produces the AL files based on tables. So what I will do here is I will take tables that start with cust, which is the customer ledger entry, for instance, right? So if I execute this, that was not fake. I can redo this, by the way. I don't do fake demos. No. So you see that? Wow. This is just actually printing to text. You see the format is completely off, but we don't care, obviously, because we have this auto-formatting thing that can handle this for us. So, empty table. This table is full of code, or might be full of code. I don't know. I just take the pieces that I want and put that into a new AL file. Take the properties that I want. I even convert the caption ML to caption, and basically go from there. And now I have my basic tables already. I can start pulling the code one by one in that I want to, again, in a decent manner. All right. Why is this back?
I don't know.
Roll. So, that was code analysis. There is another one on this slide. That is Docker.
Docker.
I hope you heard of Docker.
What has Docker ever done for us?
Well, I know that you are not an infrastructure guy, but actually when we talk about Docker, we talk about infrastructure. And in a lot of cases, we as developers are confronted with infrastructure. We need to build up development environments. And the way that Vjeko does it, well, he does a lot of manual things.
I'm a coder.
Right? So I have seen him work. I've even seen him sweat 1 hour before this session, sweating with, can I tell that? Of course I can tell that. Sweating with the VM, his personal VM on his PC that he just showed that demo from
no Docker on my PC, Docker free.
Yeah, be proud of that. Not. So that's actually his lifestyle. Shut up. So he spins up a new Docker, no, not Docker, a new VM, a new, entirely new VM, installs NAV and start coding. When he needs a new version, the same thing. And this doesn't take 2 minutes, doesn't take 10 minutes. It takes quite a long time and a lot of manual clicking. Now, I simplified myself a little bit. I can simplify myself apparently.
Do we have enough of that?
So, what I did, I have no clue where I put that.
In your Docker container.
You know what the problem is?
What's my problem?
You talk too much.
I talk too much. Don't
So,
let me get started.
install nav. So I had a script here. You can't see the screen, thank you.
That's what I'm telling you.
So I have a script here that basically helps me install nav. And this is just a quiet install of a DVD. So I was, back in the days, still very relying on the DVDs that we got and downloaded. And yeah, the download takes time, and you know the pain. The pain that Vjekoslav still goes through every single version.
Come on.
Yeah. What are you thinking, basically? Because at these days we have Docker. Docker simplifies stuff. Now let's dive a little bit into Docker. Docker is a VM, but not a VM. A VM, just a part of a VM. It's going to start an isolated whatever VM. It's called VM, but it's going to use your kernel of your host. Yeah. So it's going to reuse stuff, which reduces size, which basically increases and boosts performance. So, basically meaning Docker is fast and efficient. It is isolated. I like isolated. I was working with VMs because of the isolation. I don't want to install nav. It's definitely not servers on my Windows 10. Windows 10 is not a service, by the way. So I like the isolation part, and now we can isolate in a more efficient way, thanks to Docker. So it is actually your solution for having multiple versions of nav simply installed next to your development environment. Yeah. So this is definitely a solution for developers. You can focus on writing code. You just need to dive into how to work with Docker. Yeah. No need to worry about that. We have enough people in the community that can help us with that. I have give one referral to, he's gone, I think. No. That guy over there. For DevOps, for instance. DevOps is this build. We will talk a little bit on DevOps later on in this session, but automating your builds. That's my machine.
Yeah, sure.
And obviously this is for system administrator. Now I just want to show you one thing. What I'm using Docker for and how I'm using Docker. Now this is my Docker environment. I've got 3 environments, obviously. Obviously, because I'm using Docker on a VM. Basically combining the two, not two. Because I still do not install Docker on Windows 10, because Windows 10 at this point I think is going to improve, I heard, in the future. So I might not do that anymore, but at this point Windows 10 is not that good with Docker yet, or at least not with the containers that Microsoft built for us. So I want to use Windows 2016, and I can do that on my Windows 10 with the VM. But that brings some complexity, because when I want to execute something on my Docker container, I need to execute that on my Windows 10, which basically going to remote execute that on my VM, which basically is going to remote execute that on the container. And then when there's feedback or a file that is written that I want to get back to my laptop, I need to get the entire thing back to my laptop. So there is some complexity. Part of the complexity is solved by Microsoft. Freddy has created some nice scripts, packed that into the nav container helper, but that lives on my host, my Docker host. That doesn't live on my laptop. So I should still remote into my Docker host, and then I would be able to execute Freddy's script. So what I did, I built some more scripts on my laptop that remote execute that to nav container helper, which going to remote execute that. And I can actually simply show you that if I switch my laptop this time again. That's the guy. Let's agree. You do not touch my laptop.
I don't touch your laptop.
So this environment actually, this is a set of scripts that I'm using to, that I used actually for this environment, for these demos that I will be doing on the client. So I needed to build an environment. This environment is built in Docker. This Docker lives somewhere on a German server, because German servers are a lot cheaper than Azure. So on a German server somewhere in Hetzner, by the way. Oh, I shouldn't be doing that. In any way, that means a German server somewhere that has Windows 16 has I need to be able to contact that Docker to be able to remote Docker, but I'm working on my laptop. So I simply set up some settings to connect to that German server, which is this one. I hope that there is no password. That there is a password in the text file. Oh, it's fake password. That's good.
Fake.
And yeah, I have this one function here that I actually execute. You see quite a lot of parameters because in the background I'm also going to set up some routing so that I can actually access it as well. But just one instruction, I can rebuild that container. F5, everything done. 5 minutes, I've got a new container. How cool is that? I hope you think that's cool. This helps me a lot in my, and I can really focus on the real stuff. Okay, back to you.
Now you're using my machine again.
So as I said, there is one guy that is going to talk a lot about Docker. I can only advise to go there. It's going to be tomorrow at 1:30 p.m. And again, it's useful as crazy. So did I convince you?
Well, you definitely convinced me that you can talk. Okay. Yeah. But I'll try this thing, Docker. But still, you know, you use a virtual machine and Docker inside. Why not Docker inside Docker? Well, that guy can talk, so can I. .NET. 7 years ago, at this stage, I was preaching .NET. I was explaining to the world how beautiful .NET is, how beautiful our life is with .NET. I made my career out of .NET since then because there was not a single session at TechDays that I didn't mention or use or show anything or something from .NET. 3 years or 2 years ago, when Freddie told me we are getting rid of .NET from what it wasn't called Business Central back then, but from NAV, I said, like, are you crazy? Really? Like, you cannot do that to us. You give this beautiful access to a beautiful framework to us, and now you're taking that away from us. And over time, what I realized is that, yeah, Microsoft was really right with taking this away. So unfortunately for me, I'm here now standing in front of you and saying that it's time for .NET to be garbage collected. So, why did we even need .NET in NAV? Well, the first thing is we had to call outside NAV. So we could not just live inside of the CL code, we needed to get out of it. But yes, we did have tools for that. We had automation. Automation allowed us to go for those things. But yes, just like that guy, automation was, you know, slow, it was outdated, it came with a lot of problems. It was obvious that in a short while it will go out of support and we will just not be able to use it properly, especially in 64-bit scenarios and similar. And finally, when thinking of .NET, .NET is a part of Windows. So whatever Windows can do, .NET can do. So it made all the sense in the world that we just simply have access to that environment that allows us to do whatever we can imagine to do. And finally, NAV itself has been running on .NET anyway. So we had this beautiful access to this beautiful, powerful framework that allowed us to do just about anything that we could imagine. So in a way, it could have felt just like, sorry, yeah, I forgot to say, like, when you give access to developers to this beautiful environment, what happens? What happens when you can use .NET? Well, you use .NET. That's just obvious. Yeah, this clicker is not working. So you use it because you can, but it might not be the smartest idea out there. So when talking about .NET, we have two flavors of .NET. So the first flavor of .NET is C#, where, or it can be VB.NET or F# if you really hate yourself. You could really write a piece of code in Visual Studio in language of choice, compile it into an assembly, deploy it somewhere, we'll talk about that somewhere, and then consume it from CL. Very good thing about that was that there were no limitations. So you could imagine anything in .NET, you could do it in .NET. Even though there are things which kind of don't work, like multi-threading, for example, it doesn't quite work well with CAL. But still, you could wrap all of that inside of your C# or F# or VB.NET project in such a way that it works with CAL. So you just did not have any limitations. You could do whatever you could imagine. However, you had some problems, we'll talk about them later, but it was just all-powerful. The other flavor is what I used to call CAL.NET, because it allowed us to do whatever we could imagine from .NET just from CAL without having to call to any external assemblies. So we could use really just pure CAL to do anything with all of .NET. A couple of years ago, I've demonstrated here how you can have a piece of CL code which contains C# code in string, which compiles that C#, loads the assembly dynamically, and then uses that assembly as .NET from the code. So things like that were possible. So the biggest benefit of that approach was that all code was contained in your CAL. So when you take your FOB, deploy to another machine, it was there on that machine. You didn't have to deploy anything else. So when thinking of these two flavors and things that you could do, when choosing which approach to take, it might have felt like choosing between using a magic wand or a lightsaber. However, that's not what the real choice was between. The real choice was like, would you prefer having your finger stuck in every door that you close, or just falling down every staircase that you ever come across? Why do I say that? Well, let's take a look at a little bit of code. So what I've done is in Visual Studio, well, I should have opened it earlier, but yeah, thankfully these days it doesn't take a geological era to open it. So this is my performance test. I just want to test how fast this .NET really is. And I have a very simple test. I have a for each loop. Can I zoom it? That's a good question. This is Visual Studio, not Visual Studio Code. I don't know a shortcut for that. Is it good enough?
Yeah, that's good
it was
enough,
wrong
yeah.
one. Okay. That better?
Yeah, I think so.
Yeah. Oh, glasses. Anyway, so this is my performance test. What I do here is I create a dictionary of integer and datetime, and then I have two stopwatches. I have a loop which does 5,000 things, and inside of those 5,000 things, it adds an element or a key value pair to the dictionary, and measures that part using one stopwatch, and then does some complex operation, and then measures the entire loop of 5,000 these things. And this complex operation is really complex because it's exponentially slower, because for each key in there, it actually multiplies. So if you have one, then we'll have one. If you have two, you'll have two more. And it does some calculation based on those keys. It accesses their values, it accesses their keys and everything. So it doesn't do anything useful, but it allows me to measure the speed. So if I run that on my PC here, if I run F5 to test that, it will show me that. It will show me some results. It will show me that adding 5,000 elements to the dictionary took 10 milliseconds, and it took 964 milliseconds to do all of those complex operations 5,000 times. I'm now going to my virtual machine.
Not Docker.
Not Docker. Virtual machine, VM. That runs Docker on it.
Yeah, I'm sure.
Yeah. In here, let me reconnect. We're all tailored client. This is just there because I want to demonstrate how .NET behaves badly, and what better environment than this. Anyway, what I have here is I have this test C#. From here, I'm going to invoke this very assembly that runs this test and prints out the result of this perform operation. Just before that, I will run this perform operation from my debug folder. I will double-click this user test perform exe. It will tell me that it took 3 milliseconds to process dictionary and 683 milliseconds to process everything else. And once again, this is roughly what we get. 3 seconds, 600 milliseconds. Good. Let's try to see what happens if I run that in my role table client. I'm going to start that so that it's not offsetting or any of these measurements. It shouldn't, but still it's better that it's up there and running. And then I will just run this code unit. I will run this test C# to see how fast it happens here. So it took 1 millisecond and 500 and some. And then I'll run it once again just to see and to prove that these numbers are really roughly there. So this performance when using a .NET assembly from CAL is roughly the same as when I'm using it directly. So those differences can be attributed to what else is happening on my machine, but this is what you get. Let's now try to rewrite that, all of that, in CAL, using CAL.NET. So this is what I have. I have this test.NET, and in here I will do exactly the same thing, just CAL. So, and you know, just to be on the safe side, I'm not doing it 5,000 times, I'm doing it 1,000 times. So I will run this now, and let's take a look at how much time it takes.
Your modern client?
Yeah, I do have, this is a modern client.
Okay.
So it took 9 milliseconds to process that dictionary, which is, depending on which measurement you take, between 9 and infinitely times slower than what it was in .NET. And the other took full 7 seconds. Let's try to say, okay, since this is exponentially slower, if I make it 1,500, so just 500 more and then run this piece of code, it will take a lot more. So it will take closer to 20 seconds. I will get back to that screen and then we will see how much time it took. In the meanwhile, let's try to see why is this happening. So why is CAL so much slower than C# when doing exactly the same thing? Well, the problem is twofold. The first one is reflection, and the second one is boxing. So reflection is how, when you compile a CAL code into C#, how that C# tier is accessing your .NET variables. It is not accessing them directly, it accesses them through reflection. So every single time you set a property, you invoke a method, it has to get a reference to that method from the type, then has to dynamically invoke it. All of that takes extra time, and if you do it a lot, it accumulates. The second one is boxing. I've used intentionally dictionary of type integer and date time, because that's how you do that in C#. In CAL, you cannot do that. You can always ever declare a dictionary of type object, which means whatever you put in there will have to be boxed and then unboxed. So accessing any of the information there, again, takes extra time. This has been a little bit improved in AL. So AL does not do reflection. AL truly wraps that. And if I ran that in AL, it would be slightly faster. But it would still suffer from this boxing problem because it's still, when using .NET variables, it uses exactly the same principle. It allows you to create just objects instead of actual types. So in the meanwhile, let me just take a look how much time it took. It took 13 seconds, or is it 13? Yeah. It would have taken 3 minutes for 5,000. I measured that, I just don't want to bother you with that. So obviously, we cannot do it this way. So the way to go with .NET obviously is to put stuff in C# if you really want to retain that performance. However, when we're doing it in C#, we have another problem. We have to deploy that assembly to all of the machines that will use that. And then how can we do that? Well, we can deploy it physically on the server, or we can put it in the database, which is simpler to perform, because when you put it on a server, when you need to stop the service tier, you have to deploy it there, and then you have to restart the service tier every single time that you do a smallest change. So when you put it in the database, if you update, you just deploy a new resource.zip into database, and it works, except that it is not really like that. So let's actually take a look at this database deployment. So in here, I'm first going to stop my service tier. So it's now dead. And then I will take rid of my assembly from here. So it's not yet gone, but yep, now it's gone. So my service tier is it's stopped. I will start it again. I should have restarted it. I don't know why I didn't. And then when it starts, I will start my RTC, my modern client, not. And then I will first prove that the DLL is not there, that I'm not accessing that. There are no smoke and mirrors. And then I'm just going to deploy to the database, because that's the way to go. That's at least what Microsoft says is the way to go. So let my modern client come back to life.
It's not really modern, it's like last
Pretty
year,
modern,
so.
yeah. Oh, what's happening here? Because I will have to do 2 more restarts to prove my point. Ah, that's because of Docker.
We trust you that it works.
Yeah, trust me, it works.
Yeah.
Okay, so first, when my client is up, I will run this again. Sorry, not this. I will run that thing again, C#, just to prove that my assembly is not there. It will fail. Okay, did I just start another client session? Could be. I will run this once again. There, it says that it cannot create an instance because it doesn't have access to the assembly. So I'm now going to deploy this assembly to the database. So just so that I can run that piece of code. So I will go to control@ins. I will create a new entry called perf test. It has versions 1002 and it's .NET interrupt type. And here I will just import that resource.zip. I will take this one. So, sorry, the zip file. And then I will just run my test to make sure that this is running fine. And there you go. It has just been consumed from the database. It has run its tests and everything is fine and hunky-dory. Until I need to do a change. I've noticed that this measurement has a bug. So I want to fix that bug. And since I'm not breaking any signatures, I'm not doing any breaking changes, I'm simply fixing a bug. I'm not increasing the assembly version, I'm increasing the file version because that's the best practice in the .NET world. Unless you're doing a breaking change, unless you're touching signatures or the number of objects available, you don't change the assembly version, you change the file version. So let me just prove you that that's the best practice. Here I have my original project. I now just want to update this perf test DLL, which is assembly version 1002, but file version 1003. So, file version also 1002. I will replace it with file version 1003. So I'm going to it's in here, but I just did not create a shortcut. So I'm taking my file version 1003, which is still assembly version 002. So obviously this is 003. I'm taking it and just patching my piece of software with a new version of the assembly. Since I didn't break anything, since I didn't change the assembly version, I can still run this one that depends on that assembly. However, I can see here that it's version 003 responding. So let me now deploy this 1003 to the database so that I can use it from the database. Good. So since the assembly version didn't change, I will just go in here and I will use this one. So I will just go and I will import version 1003. And then let me restart my test to see that it's still the old version responding. There is no version tag in there. Good. Then obviously I need to restart the service tier. So let me restart the service tier. So I'll restart this service tier. Okay, my session is dead. So it's now running again. Let me run my client again. Hopefully it takes a little more time to wake up this time. Actually, let me just cut to the chase. Let me just simply tell you what will happen, because we are shortly running on time, and for some reason my Docker is not working well.
That's a good joke.
Thank you. What will happen is that nothing will happen. I will still have the old version responding, because Microsoft has decided that file versions don't matter. That the only version you can ever deploy an assembly with is the assembly version. And they tell you, well, increase your assembly version. That's fine. I will increase my assembly version, but then I have to recompile all of my CL code and redeploy all of my CL code, because updating assembly version is a breaking change. But I will do it. However, what if I, for some reason, just like you, Microsoft, use JSON.NET, which follows the best practice in the .NET world and does not touch the assembly version, not to introduce breaking changes. They simply update the file version where they want to fix a bug. What if I want to use their assembly? How do I get their assembly to deploy on NST? The answer is, there is no way. So once you deploy a file with a single assembly version, you are cemented not per tenant, but per machine. Not per NST, but per machine. You can have multiple NST instances, you can have multiple tenants, all of them will be condemned to use one single version without the possibility to upgrade in any possible way, but hacking. You would have to stop everything, then you would have to go to some system folders to clean up files manually, and then if you have multiple NSTs using multiple different versions of the same assembly, you're doomed. So some of them will work correctly, some of them will not. So, it's a bad idea to use .NET. So why is it a bad idea to still use .NET? Well, if we're using C#, we are introducing all of these dependencies which we cannot properly handle. We cannot really handle those dependencies by deploying them to the database, because we will hit a wall. Or we cannot really use those dependencies physically on the server because we might not have access to the server to put those assemblies out there. So whatever approach you choose, you're doomed. Plus, Business Central will not let you run any DLLs. Well, then CL, obviously. Well, it's so much slower, it can be so much more painful, and of course, you just cannot do everything. Also, you cannot migrate that to Azure Functions, what would be a good choice to do, and it's also very difficult to refactor to anything else. So, it's really a bad idea. So then, what can we do if we cannot use .NET or should not use .NET? What can we do? Well, the first obvious choice is inside of AL, we have a lot of AL APIs, like calling web services, handling JSON, handling XML, handling text streams, etc. So things like that work beautifully in AL and are getting improved. With every single release, there is something new in there in that arena where we can use more features to do more stuff for what we would have used .NET earlier. If that doesn't get the job done, if there are things that you cannot do with that, then you can offload your stuff to Azure Functions. And if you don't like Azure Functions, then you have a range of .NET _ code units, which are supported also in Business Central, which are tested by Microsoft, which are approved to be working by Microsoft, and that allow you to do other things with .NET using .NET, but just through a wrapper rather than directly. And if you don't have a code unit that can do something specific for you, well, you can create your own, and then you go to this GitHub and you simply submit that. And then Microsoft will simply take a look. If they deem that good enough and reasonable enough, they will just include that in the stack, and next service pack or cumulative update or next release of the product will have and include that code unit, which you can then use directly. So that's how you approach that problem.
That was a serious long story.
Yeah, obviously.
If anyone is a bit lost in the story, like me, let me just rephrase this in only one slide. .NET. .NET.
Good one.
And I want to actually talk about a small example, not really a small example, quite an example, on where we achieved actually one of our, let's say, biggest solutions that relied completely on .NET and .NET interoperability and our own DLLs and so on. And you're touching my machine again.
Sorry.
Oh, sorry, this is too soon even. This is called NAV management. Now this is an internal solution. I just want to show you what is possible going from this .NET world that we were living in and following Vjeko's rules to .NET. Yeah. So this NAV management is actually a partner solution, is our internal solution that we monitor our customers with. The typical partner problems, being able to remotely log into customers, monitor their NAV solutions, self-healing services, scripted installations. Like if we want to set up a customer, we basically do it through this tool. Looks like this. Not in a modern client. This is basically the previous version, but you can see a little bit on the infrastructure part. There is the fully automated install, our connection to our customers, these kind of things. So an infrastructure solution, a software solution to an infrastructure problem. Yeah. We want to approach our customers as being cloud customers, but they are still on-prem. That is basically the idea. Thing is, Business Central and Vjeko is actually moving us into a non.NET solution. So we needed to move this in, and into another solution, in not being that dependent from our DLLs and these deployment issues and all that. So we completely rebuilt or are rebuilding the solution. And this is the architecture that we are trying to build, or actually are building. So we have Business Central. We have a completely outside API, a web application, which is going to do our funky shit.
You said
stuff. I said it. Yeah, I cannot take it back anymore. Yeah, okay, funky stuff. This funky stuff used to be in these DLLs, okay, and in the .NET interop and all these kind of things. Now we want to move that out. So this is very comparable with Azure Functions, for instance, but we didn't do it with Azure Functions. We wanted to be completely free from Azure Functions and build our own web app. On the right part, you see an agent which is basically pushing the buttons at the customer side, and we are able to remotely connect to that agent. Let me try. The communication between Business Central and all the external services is pure REST calls, pure web service calls, nothing else, nothing at all. Okay. So let's see that in practice. And now I can switch to this one. So this is how it looks like in a modern client. This is how it looks like in a modern client, by the way. So this is just the start. Definitely less as you have seen in the screenshot. The screenshot is more, but this is an environment that is building up. We are refactoring this solution into removing the .NET part and moving to this API approach. What I would like to show is one functionality, which is a remote desktop functionality. Being able to remotely connect to any kind of server, we need to be able to monitor or administer at the customer side, on-prem. Yeah? So obviously this is a test environment or a demo environment. So I just set up some connections to 2 of my servers and 1 of Vjeko's servers. And you can see here I've been helping Vjeko's in probably setting up. I can see connection details. Yeah, Vjeko has no clue how to work with Docker. Nope. So we can not only solve this, let me say it another way. Customers always want to know when we log in their environments and why. Well, there's a logging behind the scenes. So we log who logged in, when, how long, with what credentials. Yeah, and also these credentials is GDPR related, quite sensitive. We do not distribute credentials to our developers. Developers do not know any credential for the customer side, but still they need to be able to log in. Yeah. So that's all things that we save here, and basically we set up the connection. And let me just simply connect or reconnect to Vjeko's machine. This is one of your demo machines, right?
Yep.
So yeah, let's just do that.
That's what I used to prepare.
So this is just a customer Vjeko. His agent is this development machine with the admin account on, which is VM admin, which you should recognize. Just a demo NAV TechDays. So this is the logging that we do in the background, which is mandatory. And then we connect. Now there is this funky thing going on. So Business Central connects to the API. The API connects to the agent asks for details, sets up.
Oh, come on.
Yeah, you need to close your browsers.
Yeah, man.
Anyway, I might have set that up.
Really?
Yes.
Yeah, that looks like you.
But in any case, I've taken over his environment and logged it as well. You see here the URL, by the way, that actually does the magic in the background. There's a URL to the API, and I will switch back here to the API. Yeah, okay, I need to show this first. Anyway, I will show this first. So this is the app in the background. We are rebuilding this as an app, as an AL app, and if you look closely, you will see that it is a real extension. There is no .NET going on in the background. I am not able to use .NET in this application. So this is the story that I wanted to do. So what the Business Central does, it creates a connection, asks a token from the API, the web app, gets it back. It calls this URL with that token. In that case, API is going to connect to the agent. The agent gets some details, opens the service bus, and I didn't redo my slide here, so service ebus, opens the channel at that case, in that scenario, and then opens the connection, which I don't have open anymore, but I just want to show you one more thing. If I redo that, so I will just put something here. Now you closed it, right?
Yeah, go ahead. I bombed it now.
You see here, there is not even an IP address. This is not a direct connection. This is a connection through the service bus, and this connection or this channel is basically garbage collected, let's say, from the moment we close the connection again. Very safe, how it should be. All possible without
not a single .NET variable.
.NET. I need to switch. This is just a piece of code that is actually creating the connection. And if you look, for instance, at the last line, that is the hyperlink with the token that opens the connection basically to the API. Okay.
Azure. Yeah. All of this is obviously possible with Azure. Azure is an important part of technology stack. And when talking about Azure, let's first try to get a look at the story of 2011. Back in 2011, when Azure came along, the #1 question was, wow, this is really cool. Is there anything we can do with Azure, we, the NAV people? And the answer was not much, really. So back in 2011, we could have used virtual machines if we wanted, and then people tried using those virtual machines to deploy NAV to Azure, until a couple of years later, it was suddenly possible to use Azure SQL databases. Then it was possible, of course, to use Azure Active Directory. And as time went on, Azure grew. So the Azure landscape today looks something like that, with all of different services that we have inside Azure. And those blue ones are those that we have seen from NAV. These days, using NAV without .NET, we can connect in this or that way to all of these that I've marked blue, probably to some others, just couldn't bother. So the entire Azure landscape has really changed a lot. So if you go back to that question of 2011, can I do something with Azure? The question of 2018 is, can I do anything without Azure? Because that's what is currently possible. Like, we can really just take any of those services, as you will be able to see soon, and do something crazy that was even unimaginable. So back to this slide. Of course, we cannot talk about all of these blue ones. I've just picked 3 most prominent ones. We will actually show only 2, not only just because we are running out of time. One of them we have showed thoroughly last year, so you can really watch the session on YouTube. So, Waldo, I really cannot talk anymore, so can you just take over? Machine learning, you're better at talking.
Yeah, when we talk about machine learning, one of the most new topics, I guess, connected to NAV. Well, I'm not going to talk too much about that either, because there are too many services. Really, a lot of them are very interesting for connecting to an ERP development, like Business Central, but a lot of them are not. I wouldn't know why you would like to do text analysis or translation. Maybe, yeah, translation might be an interesting one. In any case, today there was a session already that handled quite some machine learning part. That is a very important topic, and you should look into it. Building your own models. Microsoft already introduced you to a few functionalities where they implemented machine learning, like what? Cash flow forecasting, for instance. Now, as said, I'm not going to bother you with that. People already bothered you with that, and if you haven't seen that, go and watch YouTube. But from all these services, there is another one that might be interesting, and Microsoft is actually already using. You must have seen demos of, for instance, Marco did it, I think, on some keynotes, that he imported a picture from himself onto Contact, and all of a sudden, some machine learning or AI technologies recognized that he was a 30 or 40-year-old man. The thing is that Microsoft built this on top of a service in Azure, computer vision. You can build on top of that. And let me show that in a small demo. So this is the smallest demo of their demos. I'm going to save this. So this is an example where I have a code unit with, where actually this is the magic, where I'm actually reusing code units from Microsoft to do my own vision analysis, right? And you can build on top of that. You don't have to do any magic, just reuse what Microsoft is already using. What I did is I put that here in the cloud on my German server. Image analysis, because German servers are not only cheap, they are fast. And what you can do is here, well, this is just a list where I can import pictures, and then it's going to recognize a little bit more than just the gender and what is it, the age. I want to tag basically everything that it can tag. So in this case, a toy, doll, dressed, and so on. And in my case, a 39-year-old male. I was lucky.
Yeah, you were lucky.
And it should do that still, maybe with Vjeko's picture here. Very old picture. This is actually from 5 years ago. And 5 years ago, he was a 45-year-old karate man.
Wow. Yeah,
Cool.
That's quite some machine learning.
Obviously, this is not really hocus pocus. That was also the idea. This is not hocus pocus. This is what you can already do by simply reusing what Microsoft is already putting its work in. It's already a big framework to do not facial recognition, but at least cognitive services, recognizing properties from picture. 45, 5 years ago. That makes you 50.
Yeah, you know, when you look this good at 50, talk to me.
I also would like to refer to the session, and we put that one of the last slides, because this session is going on at this very moment, and we didn't want you to move out of this session. So, and which are doing crazy things with other services on Azure. Last but not least is the Azure DevOps part. Another service from Azure. Actually, is this really a service from Azure? Let's call it a service from Azure, because they renamed it from Visual Studio Team Services, yeah? Which is now called Azure DevOps. Now,
yeah.
can I ask, who is source controlling their CAL customers? Oh yeah, maybe clap because I don't don't see a thing. Okay, so that was not a lot. So can I reverse that question? Who is not source controlling their CAL customers? That should be anywhere else, right?
What other option was available?
The question is why not, and I will tell you why not, and you know why not, because CAL didn't really make that really accessible. Source control was quite a challenge. Going one step further is continuous integration and continuous delivery. This is a hot topic these days, but what is that? Well, when we talk about continuous integration, we talk about continuously integrating code from developers. Yeah? Continuously merging. Just imagine that when you're doing AL development, not CAL, but AL development, all these files are locally on your PC. At a certain point, they need to be merged. We are going to merge the bejesus out of ourselves. Yeah? Continuously. So best practice is that something automatic will do that for us. Not only that, at a certain point, we will have to deliver the code to environments, like our test environment, like a live deployment. Yeah? So, basically we are talking about source control on steroids. Basically we talk about working in team. Just imagine that all these files are spread on your PCs, but you're still working in team on one app. Yeah? Continuously merging, continuously testing if everything still works, because I might be developing one feature, the other one is developing one feature, and the third one is developing a feature. At a certain point he says, yeah, merge it, but does it still work with my code? Because we never touched each other's code. Yeah? You're not developing in one database anymore. So this is a concept that is quite new for our world. I've got 6 minutes and 48 seconds to show you that.
Go on, sure. Thanks to you.
Just talk a little bit about the challenges. Just imagine you're doing an app for app source. This app for app source is probably for multiple countries. So just the database that you're developing in is not enough. You're actually developing in 15 databases because it needs to be able to run in 15 localizations. Yeah? How are you going to set that up? Well, you're developing in one environment, you're building in all the others. Yeah? I'm not going to spend all times, but there are all the challenges here. There are dependency challenges, like dependency challenges, automated test challenges. How are we going to test in all these 15 environments? And then the test environment. This comes later. When everything is tested and built and compiled, how do you get that to an environment that your consultant can check that is actually that's it what it asked for? It compiles and all. But is this what I asked for? And if you do a rebuild and you deliver again to this QA environment, is it still what I'm asked for? And where's my data that I just set up previously? I don't want to lose data, and so on and so on. It gives you a lot of challenges. Challenges that you can solve with a combination DevOps or Azure DevOps or build automation and all these kind of things. And PowerShell. Oh, this is too soon. There's good news. The good news is VS Code comes natively with Git support, so source control is going to be hard to not do source control, right? So next year, everyone. Azure DevOps helps you setting up this continuous integration, continuous deployment. Yeah. And last but not least, Freddy is there to help you as well. He has got lots of scripts that helps you setting up this build, setting up this this delivery. Yeah, just go to that blog. I have 4 minutes. I shouldn't be doing this, but I'm still gonna do this. Just to simply show you, and I'm not going to do the complete demo, but show you how this DevOps could look like. So I got here my NAV TechDays 2018 project with a repository of my simple image analyzer. Yeah. Now, whenever I push a change to a certain branch, and I have 2 branches here, I, as a developer, need to mark this development as closed. Like I can push multiple things to this branch, but from the moment I say, yeah, ready, then I can create a pull request. I can request my master, being the dev lead, still in the Jedi mood.
Yeah, obviously.
I can ask him to pull my code, and that's where we create pull requests. And you will see here that I have a few completed pull requests already. And that results into some kind of build. This is where actually our DevOps or our continuous integration comes into play. It's going to test if everything still works. And you can see here what is it going to test, right? It's going to compile my code against the current master. It's going or against multiple versions. It's going to run the test application, and it's going to even capture the results of the test. I can even see here what it did for test, and I hopefully 100% of my one test failed. Succeeded. I only have one test and 100% succeeded. Nice thing is, from the moment I have a build, from the moment the application DevOps decided, yes, you did a good job, I could build you an application, I've got you an app file, I can also automatically deploy this, and this is basically a release pipeline. Sorry, I clicked the wrong one. A release pipeline to, in my case, to this online environment on this German server. So this is again where Docker and my remoting Docker comes into play, because I want to move this app file up to my remote environment, install there the app file that I have just built with the automatic build. Meaning, from the moment I create a pull request, let's say 7 minutes later, it's deployed on a test environment, and I don't have to do anything. Try that with Seaside. So, tomorrow at 11 a.m., these three fellows are going to show you a lot more regarding continuous integration and continuous delivery. You have anything to say?
Nothing more to say, man. You can talk. You know,
Mr. .NET.
I love this session.
Why?
Because it's over. So, we said all we had to say. So, your turn now. You have 1 minute 37 seconds. Go. If the question is good, you can earn a T-shirt, and keep that away from me. I kill people with that.
I know, but I will throw this. Oh, whoa!
Yes, if you can't, okay, if you can't use .NET functionality directly, is it possible to use it via JavaScript, for example? And if the answer is yes, are there any limitations or disadvantages?
Sorry, I must admit I wasn't paying really attention, because Waldo was taking over and I was just in the...
I was just throwing in the mic, and when
Yeah,
I heard
yeah.
.NET, I was like, oh, this is a Vjekoslav.
Really, sorry, yeah.
Okay, should I repeat the question? Or? Yeah.
Sorry?
Should I repeat
Yes.
the question? Okay.
Yep.
My question was, if you can't use .NET functionality directly,
Yep.
is it possible to use it via JavaScript, for example? And are there, if the answer is yes, are there any limitations?
You mean JSON script? What do you mean by JavaScript?
JavaScript.
Well, JavaScript doesn't have access to .NET directly anyway. So you would, if you would want to do something like that, theoretically you can do that, but the implications that you have are just huge. So, for example, how I would imagine that you would have some kind of a service sitting on a local machine where JavaScript can talk to that, but then that local service would have to run on HTTPS, not on HTTP, because otherwise you would not be able to consume that from the client. And if it's running on HTTPS, it has to have a certificate which you need to update, because otherwise the browser wouldn't trust it.
Yeah,
Or if it's self-signed, you would have to somehow establish that trust on every machine. So it would be painful.
Yeah,
So I'm sorry. Yes, you could call Azure functions as well, but then you don't need JavaScript for that. So, yeah.
Okay, when are you planning to go on Europe or world tour with your music? That's the very important question.
When you invite us.
You get 2 T-shirts for that. Yeah. Thank you.
Give me that. Let me kill somebody.
No. Be careful.
Yep. Come on. Who dares? Well, see, I can do it.
You
And
throw
I'm
like a girl, man.
Thank you. These automation tests, is it I don't understand it. Is it using external tools, for example, like a job queue or something?
Which one?
The Azure automated tests, the Azure DevOps, the automated tests,
tests.
pipelines.
Mhm.
Is it like a job queue enough that calls something different external?
No,
or
nothing enough. You need that. It's DevOps. So from the moment basically you commit, right, and you push your changes, it starts doing that. So you have triggers in that DevOps that can automatically be triggered from the moment you do something. So what I did is from the moment there is a pull request, it starts building up. So there are agents somewhere from DevOps, agents on servers. So you saw these two Waldo servers. I opened Vjekoslav server because it's something to show. But I opened these Waldo servers were actually these agents from DevOps that are constantly waiting. From the moment that Azure DevOps says, okay, I've got a job for someone, it finds an agent, and it finds an agent, and it starts doing that. So obviously I need to install stuff on that agent, like Docker, like there is a Docker part that is going to be, downloading an image and compiling my code at that point. So it's a combination between an agent from DevOps, PowerShell, and Docker.
Okay, so there's no pipeline called auto-merge and it works, so you have to set up a PowerShell, for
at this
example,
point there is no Azure DevOps template that you can use. You need to do a little bit of manual work, yeah.
Eko's first funky demo with Node.js, was that driving the client, or was the client calling the Node.js?
My Node.js demo involved only Node.js, but the only thing I showed in Node.js was those crazy truthy-falsy JavaScript Boolean logic. My first demo was the client.
Right.
What is the question about?
So was the client basically using Node.js to show the images?
No. There was
There
was no Node.js involved. So what I did is I did some JavaScript hacking to achieve that. Yeah.
Is that something we
It was
can do?
hacking. So that Muppet client modern client was hacking. I actually, I would have done it all using Control-N, except that I couldn't show the splash screen using Control-N. So for the purpose of the splash screen, I did some hacking. But other than the splash screen, everything else, it can just be done with the Control-N, just pure, simple Control-N JavaScript, clean and neat.
Right, so we could do stuff like that if we wanted a funky demo.
Yeah, if you want to, yeah.
Okay.
Yeah, if you want to funky demo, you can do that. I wouldn't be doing that.
You can create schemas, apps, and publish them and sell them, yeah?
But you mean like themes and stuff like that? Yeah, absolutely. Do you want a Muppet theme? I can do a Star Wars theme next time.
I want Harry Potter. I mean, not Harry
Yeah,
Potter.
you are a lightsaber man.
You don't want us to use .NET. How do you want us to access like local resources like serial ports and USB devices?
Local resources.
Yeah, local devices attached to the client. For example, USB
Well,
devices and so on.
Like service bus is one of the options. Waldo has just shown that. So he was accessing a VM. He can access some other local resources. Then that question that I explained is another way. Like you could have a local service running on your local machine that you could do.
Just to avoid making
Yeah, I
service
know.
on
It's
client machines.
yeah. If without having something running locally, which is either a service that responds to either your JavaScript or something in the service bus, or without building the entire client wrapper yourself, you cannot.
Yeah, .NET again,
just
sorry.
Come on, ask that guy something about PowerShell so he wakes up.
Actually, we are 5
Oh,
minutes
Docker.
overtime. We need to stop.
Docker.
Last question.
Let's contain
Oh, I
you
don't
in
see
Docker.
anything
So
actually. Someone. Yeah, you again?
you don't get the shirt.
You don't get a shirt because I don't have
Can
it.
you play something for the end of this session? The Pioneer?
We didn't plan to.
Well, let's play that theme again.
Okay.
Do you want that?
Now we have less stage fear than at the beginning. I love this song. Thank you.
Thank you.